When you throw a ball, the path is always a curve. That curve is a very important equation in math, and it is a quadratic. You might have seen before a linear equation, but the quadratic is a little bit different because it can model curves. This, what I wrote here, is the general form. Now, a quadratic will look something along the lines of this. Now, if you're wondering what the equation of this graph that I drew is, it's y equals x squared. This is called the parent function or equation of the quadratic. So what are the meaning of all these variables we see in this general form? Well, the y is just the y coordinate, and we can use this ax squared plus bx plus c to actually find the y coordinate. The x is obviously the x coordinate, and we can do some fancy stuff by plugging in some values for x to find some values like, for example, the y-intercept. The a cannot ever in a quadratic equal to 0. Because think about it. When the a equals to 0, this quadratic function becomes a linear function. Why? Well, anything multiplied by 0 is just going to end up being 0, so we can just cancel this term out, leaving us with bx plus c, which is a linear because it's x to the power of 1 and not to the power of 2. Now, before I explain what the b means, it's very important to realize what the graph I drew actually is. This curve or cup or whatever you want to call it actually has a mathematical name. It's called a parabola. What does the b value do to a parabola? Well, it just determines the position of it. When we end up learning how to factor quadratics, we will get the x-intercepts, which is what mainly the questions ask. The b is pretty important to influencing the x-intercepts. Now, what is the c? This c value is also extremely important. The c will always, in a quadratic, tell you the y-intercept. What is the y-intercept? The y-intercept is the point where the graph crosses the y-axis. And in this graph, because this is the y and this is the x, this is the point, well, let me make it in red so it's more clear. This is the point where it crosses the y-intercept. Remember, in the y-intercept, the x is equal to 0, and in the x-intercept, the y is equal to 0. Now we're going to move on to a very important topic. It's called concavity. Essentially, concavity tells you whether a parabola is opening downwards or upwards. We call these two concave up, as you see here, and concave down. I'm plotting these at random points. So concave up happens when the coefficient next to the x squared, which is called the leading coefficient, is positive. Whenever it's positive. So something like 4x squared, we look at the leading coefficient, it's positive. Now, remember, this is not the entire quadratic. There's probably going to be some like 3x plus 2, and this entire thing is equal to y. Just keep that in mind. But we're only focusing on the a value as we studied in the standard or general form. So remember, when it's positive, it's concave up. However, when the a value is negative, it's concave down. How I like to think about this is when you're positive, you're happy, you can kind of see a smiley face right there. But when it's concave down, you're pretty sad, you're negative, you can kind of see a frown. So that's a way to memorize concavity in a quadratic. And one last thing I forgot to mention is, let's say you have negative x squared. Some people get confused, well, because where's the coefficient? You don't see the number next to x squared. Where's the leading coefficient in this quadratic? Well, if you think about it, negative x squared is just negative 1 times x squared. There's always a 1 next to that negative. A lot of times in math, these things come up, and you just have to get used to it as you get more and more advanced. So what are some key features of a quadratic? Let's focus on first the y-intercept. Let's think about a random quadratic. Let's say 2x squared plus 10x, and let's say minus 5. Now to find the y-intercept, remember you always have to just plug in x equals 0 and you always get the y-intercept. If you were attentive, you would realize that you can already tell that the y-intercept is this last value here. If you think about it in terms of a graph, the y-intercept, as stated before, happens when the quadratic crosses the y-axis. And at this point, no matter what the y-coordinate is, the x-coordinate is always going to be 0. So we can just input this 0 into the x of both of these x's, and then we will get the y value. We already know it's negative 5, but let's just do it methodically. So 2 times 0 to the power of 2 plus 10 times 0 minus 5. 0 to the power of 2 is just 0. 0 times 2 is 0. So this just cancels out. 10 times 0 is also 0. So this also cancels out. And negative 5 is all that's remaining. As you can see, the negative 5 equals that over there, which is the c as we discussed in the standard form. Next, x-intercepts. These are a little bit more difficult to catch, but how can we find the x-intercepts? It's important to note that x-intercepts can also be called roots or solutions. So roots or solutions as well as x-intercepts. So questions can use these kind of synonyms. If real solutions exist, that's where the parabola crosses the x-axis. Let's say you are given y equals x squared plus 12x. How would you find the x-intercepts of this equation? Well, if you factor out the x, you have this. Now, it's kind of the vice versa of what the y-intercept is. So think about it. What do you know for sure about this point? You know that no matter what the x value is, the y value is always going to be 0 at the x-intercept. Correct? If you just draw a line, you just end up at y equals 0. The same for the y-intercept, you end up at x equals 0. So both of them are kind of vice versa of each other. So what do you think we can do here to find the x-intercepts? Well, we can just set y to 0. So x plus 12. Now we have to split these apart. Take the x and make it equal to 0. And we can take x plus 12 in the parabola and also make that equal to 0. Now, usually you can't do this, but because we're dealing with a quadratic and we set the y to 0, we're able to pull these x's out of their equation and set them equal to 0 to find the x-intercepts. So one of them is already pretty obvious, that x equals 0. Now the other one, you have to just take away 12 from both sides and you get negative 12. So x equals negative 12 is your other x-intercept. How would this look like on a graph? Well, we have our y-axis, we have our x-axis. Let's say negative 12 is around here. Let's say 0 is around here. Let's plot this. Let's say it looks something like this. And what would the concavity of this quadratic be? Concave up, because if you look back to our original equation, it has a positive leading coefficient. There's just a 1 over here we cannot see, but the 1 is indeed positive. Therefore, we are opening upwards. So we covered the y-intercept and the x-intercept. Next, we're going to cover the axis of symmetry, another very important rule. So what is the axis of symmetry? Well, let's draw another quadratic over here. Let's say it looks something like this. Now, the axial symmetry, which is x equals negative b over 2a, will always tell us the x-coordinate of the vertex. Now, the vertex is the minimum or the maximum point of a quadratic. If we go back up to where we covered concavity, we have a minimum point when it's concave up, and this is right here. That's the minimum point. And we have a maximum when it's concave down. So if you want it to be simplified, when you have concave up, notice how the rest of the quadratic is kind of higher than this like 1 point, and that's why it's like the minimum it has to be. And the concave down, the rest of the quadratic is below it, so more negative, so that's kind of the maximum point. So remember that the vertex can either have a minimum or a maximum, but in concave up it's always minimum. So again, x equals negative b over 2a gives us the axis of symmetry. Now what is b and what is a? Well, if we go back to our general or standard form, we can really just see what is a and b. So if we plug those in, no matter what the quadratic, we will always get whatever the x value is of a vertex. Now let's say this parabola represents this function right here. So y equals x squared, let's say plus 6x, and that's it. But we can also find the y value of the vertex if we take whatever we got for the x value and plug it in here. So let's do this for our function. X equals negative b over 2a. That means x equals negative b, this is b, so negative 6 over 2a. There's a 1 over here, so 2 times 1 is just 2. X equals negative 3. So we know that negative 3 is going to be the x value of the vertex. Now all we have to do is just find the y value by plugging in negative 3 into our function. Y equals negative 3 squared plus 6 times negative 3. Y equals negative 3 squared is 9, because any negative squared is going to end up being a positive. 6 times negative 3 is minus 18, or negative 18. So 9 minus 18 is just negative 9. Y equals negative 9. So knowing these two coordinates, we can say with absolute certainty that the vertex of this function is going to be negative 3 and negative 9. And if I forgot to mention this, it's called the axis of symmetry because it's basically a vertical line cutting the parabola in half. Now let's go ahead and try some practice questions. I'd encourage you to pause the video and try these for yourself, and then unpause when you are ready to see the solutions. So the first question is asking us to find the y-intercept, and I'm giving you guys a little bit of a hint by showing you guys the standard form. Ax squared plus bx plus c is a quadratic. So the c is actually the value of the y-intercept. So we can just immediately get the answer, which is 0, 5 is the y-intercept, or you can say y equals 5. You could also plug in 0 as x, because at the y-intercept you can see that x equals 0, but this is just a more efficient method. Find the x-intercepts, roots, or solutions. So we did this kind of problem before. First, we have to factor out the x. Now recall that at the x-intercept, the y value is 0, so we can set y to 0. Remember, we can extract the x's from the function. So the x will equal 0, and also x plus 4 equals to 0. These are separate, just so you guys know. Now we already know that one of the answers is x equals 0. And if you subtract x from both sides here, x equals -4 is your answer. Now the last question is asking us to find the vertex using the axis of symmetry. So if you recall, the equation for the axis of symmetry is x equals -b over 2a. So in this case, -b is just -6 plus another negative, or with another negative, and two negatives multiplied by each other make a positive. So x equals 6 over 2a. There is a 1 here, so it's just 6 over 2, meaning it's 3. So x equals 3 is one of the values of the vertex, so we can already plug that in. Now if we plug in this value of x into the original function, we can get the y value of the vertex as well, or the y coordinate. So y equals 3 squared minus 6 times 3 plus 8. Now we know that y equals 9 minus 18 plus 8, and y equals 9 minus 18 gives us -9. -9 plus 8 gives us -1. So y equals -1. We plug that in to the vertex, and we get 3, -1 as our answer. So there you go. Hope you learned something new.